My name is Salem, like the cat, if you know about the cat. Um, my pronouns are he, him, and I work at Etsy. If you don't know Etsy, they're a marketplace for handmade goods and vintage stuff. And we're hiring. So if you want to hire, come find me. There's like a whole contingency of Etsy people here as well. This is my very first conference talk as well. So if you have any feedback for me, please do not withhold it. I would love to hear about it. So, OK, cool. So I wanted to talk about how we migrated from an in-house written build system to Webpack. Yes. And specifically, I want to talk about why it took us so long to do that. So a little bit of detail about what I do. I work at a team at Etsy called the Web Platform team. If you've ever worked at a place that has a front-end infrastructure team, it's probably very similar. Our whole job is to manage how Etsy writes and builds stuff like CSS and, more relevantly, JavaScript. It's probably why you're all here is to hear about the JavaScript part. This talk is essentially about how we moved from one build system to another, but this doesn't mean that I'm going to talk about how to write a config file or how to get brand new ES6 code running in really old Internet Explorer. My goal here is to talk about the weird problems that we unearthed and how we fixed them and where all my hair went. So this talk is like about 5 parts. I'm going to first tell you a little bit about Etsy and our old build system that we called Builda. I'm going to talk about why we picked Webpack. I'm going to talk about some of the development headaches that we had, some of the production headaches we had, and then this really weird bug that we experienced while rolling it out, in which 4 milliseconds delayed our launch by about 3 months. So that's going to be a fun one. So if the beginning parts are boring, at least stay till the end. So before I get into it, there are 2 big old caveats that are worth mentioning. Number 1, the decisions that we made were true for us at the times that we made them. There may now be better alternatives because JavaScript changes really quickly, but they either weren't around for us or weren't battle-tested enough for us to use them. JavaScript, as you all probably know, changes very quickly, which is the whole reason that we wanted a really flexible build system in the first place. And number 2, all of the things that I'm going to talk about today were big team efforts. I know a whole lot about how Etsy's front-end infrastructure works, but I'm speaking on behalf of my whole team. I think my voice kind of disappeared. But I'm speaking on behalf of my team that collectively built and researched all the things that I'm going to talk about today. They kick ass, and I really, really love working with them. I think Joe is right up there somewhere up front. That's my teammate, Joe. There's also John and Natalia, who are not here right now, but they're just wonderful people to work with. All right, enough of that. I'm going to get started with the actual talk part. I'd like to talk a bit about Etsy's codebase and Etsy's old build system. It's hard to tell you about a migration process without giving you a little bit of context. So here it is. This is Etsy's codebase. It's a lot like any other codebase at a medium-sized company. It was once small and weird, but then it stayed weird, but it got really big. Some things scaled really well, and some things did not. Most of our live code lives in one big monorepo. That is to say that the code that makes Etsy show up in your web browser, from our API all the way down to our CSS, lives in one repository. We call our monorepo Etsy Web. People have different opinions about monorepos, but it's worked surprisingly well for us. It has helped us facilitate learning, and it's made finding examples and reusing patterns really, really simple. However, one thing that did not scale very well as we grew was the JavaScript part of our code base, and more specifically, our JavaScript build system. That's a compactor. So this system is something that we named Builda, and we named it because it built a lot of assets. It was written in-house more than 8 years ago, and it existed in various incarnations ever since. For all intents and purposes, it did its job really well for a really long time. For those of you who may not be familiar with JavaScript build systems, a build system is something that just takes our files, resolves their dependencies, bundles them together, makes them as efficient and as small as possible, and makes them work in a. I think can you still hear me OK? Cool. Cool. Just wanted to make sure you're all still there too. It's to make sure that all of our bundles work in different locales and browsers all over the world. This wasn't that our JavaScript was particularly sophisticated when Build-A-Pack was first written. We got to hit play on this part. It's going to be like a carnival game where I have to aim on a screen. Boop. One more time. Hey, there it goes. OK, so when Builda was first written, Etsy wasn't this really sleek, interactive homepage that you can see here, complete with image carousels, overlays, cool animations, and a responsive navigation bar, and a really cool branding. Looked more like that. JavaScript was just decoration on top of a really highly server-driven experience. Having one file depend on another was pretty infrequent, and when that did happen, it was usually for large, globally scoped libraries like jQuery. For a long time, our code didn't take a lot of work to turn into a production-ready asset. Few dependencies needed to be resolved, and nothing needed to be transpiled. Production builds took very little time. At Etsy, this is pretty important. We deploy code dozens of times in a single day, and slowing down a deployment is something that we try to avoid at all costs. So developing JavaScript was similarly pretty simple. That's supposed to be me. If we load a page in development that requests some JavaScript, that JavaScript file would be built from our source and sent back inside of one request. To keep track of all the possible files that we might need to request, we kept a list of all of them, which we brilliantly called the build list. When we served a file, we'd make sure that it was in that list somewhere. The build list was used in production then later to determine the entirety of what we needed to build when we deployed our. In development, if a requested file was not in the build list, we'd respond with some JavaScript that throws an exception telling you to add your file to that list. This ensured that we could essentially build any file we wanted on demand while making sure that we knew the extent of what we needed to build by the time we were ready to go to production. We used require.js to manage and resolve our dependencies. Maybe you haven't even heard of this because it's a relatively old library, but we still have been using it, and it's pretty simple up until we moved to Webpack, that is. We first start by sending a copy of require.js to your web browser, and then we follow it down with some of our own code. Require.js then allows our own code to then use AMD-style module definitions, as you can see here. For some of you, this might sound like it's out of the Stone Age, but for us, it was pretty cutting edge at the time that we did this. AMD stands for asynchronous module definition, which is just syntax for defining modules and their dependencies. We define an array of imports, which require then resolves for us. Those imports then get passed to a callback as arguments, and all of our code goes to the body of one of these callbacks, where it has access to all of the imports. Builder's job was to make sure that all of the necessary modules needed on the page were bundled into one JavaScript file, so that require.js had access to everything it needed in the browser. At some point, React came along. For those of you who are unfamiliar, React is just a library that makes writing large client-side applications a lot easier. Sometime around 2016, we decided that it would be a really good fit for some of our seller tools. When we decided to introduce React to our codebase, everyone was excited. React, however, strongly relies on JSX, a syntax that looks like HTML, controversially aligned into JavaScript. If we want to be able to use this syntax, we need to make a build system that can do more than just glue files together. It also had to be able to convert JSX back into regular old JavaScript. So we used an old version of the compiler, and we non-trivially bolted it onto Builder. It's a stapler. This allowed us to turn React's. I added the staples like last night. I was like, oh. This allowed us to turn React's custom JSX into plain old JavaScript. There was one problem with this setup, however. Because we built every file only when it was requested, rather than whenever some part of it was edited, we had no way of knowing if it had changed or not since the last time it was requested. So we had to rebuild every asset every time we wanted to use it. Transpiling JSX into JavaScript added a bit of work to this step. So as we relied on React heavily, ended up taking a good bit longer to get served. But JSX was new, and it wasn't used in many places yet, so very few people felt the pain of long build times and rebuild times in development. Besides, how bad could it get? It's just JavaScript, right? We know that didn't last very long. All of these quirks together meant that loading something large, like a single-page app, implied rebuilding the entire thing from scratch every time the page reloaded. Plus, our code base was only getting bigger. At last count, we had over 1,000 separate JavaScript assets to output, making up of over 11,000 separate individual modules. React code was used in a lot more places, and it started to take the better part of a minute to show up on the page in development, which made iterating very, very tedious. On top of this, developers were starting to ask for the ability to use ES6 syntax and features. It felt like a non-starter for us. React support was difficult to implement, and though it worked, it certainly wasn't sustainable. Repeating the process with ES6 felt like a non-starter. We knew we needed to do something. This is where I've told myself that I'm going to drink water, and you are all going to take 15 seconds and introduce yourself to the people who are right next to you so that you don't hear me gulping over the microphone.
OK, cool. So I drank my water, and it is now time for me to talk about the solution to every one of our problems. People started talking around this time about this brand new open source build system. It was called Webpack. You might have heard of it. These are all the GIFs from my entire presentation. They're just right here. All right, any new developer that we hired asked if they could use Webpack, and the internet made it sound like every tech company that used JavaScript also used Webpack. While it's always healthy to be skeptical of things that it sounds like every tech company is using, Webpack did sound kind of interesting. It sounded a lot like Builda in that it built stuff, but it also sounded very different in that it had a robust development experience, it was highly extensible, and it had a bunch of built-in performance optimizations for our code. Most of all, it was supposed to be very fast, especially for development. So we did a little bit of research. Oh, I just wanted to point out this is a fast chicken. It's a recurring motif, so keep it in mind. So we did a little bit of research. We evaluated a bunch of alternatives. And we decided that going down the path of building our JavaScript with Webpack instead of Builda was the right path. Our goal was to create a new system that inevitably would act a lot like Builda. We had two requirements for any new system that we'd want to adopt. Number one, it would have to be able to take care of development builds without too much interaction from developers. One of the nicest things about Builda was that despite its slow build speeds, you could navigate around the entire site in development without worrying about how the build system worked. And the other requirement was that I would have to build our production code in about 5 minutes. As I mentioned before, Etsy deploys code to production dozens of times in a day, which is a core part of how we work. If our builds took longer than 5 minutes, Etsy's deployments would slow down, which is not a good thing for us. So, Webpack. What was cool about Webpack for us? Well, it's highly configurable. Instead of a build list, Webpack uses a configuration file, usually called something like webpack.config. It is in the same file that you specify every aspect of Webpack's behavior, from how you'd like to support templates, if any, to what sort of performance optimizations you'd like to make. This oftentimes means really large, really scary config files, which isn't always the right idea for small projects. But for a large code base with weird quirks everywhere, having something that could adapt and fit to our code was very invaluable. We spent a while writing out a really nice webpack.config file, and we also spent a lot of time writing very good plugins and loaders to emulate different features that Builda currently supported, which at the time included everything from transpiling templates to inlining SVGs. After spending hours setting things up just right, we finally got Webpack to build our whole code base. But it wasn't quite what we expected. It took about a half hour to do. It ate up 20 gigs of our server's memory and maxed out every single one of its cores. This is a real screenshot. And it had the unclear progress indicator that everyone has come to know and love. This made it exceptionally hard to figure out why it was so slow. So we definitely had a lot to learn about improving Webpack's performance. But at the end of the day, we needed to change a lot about how our code base looked and about how Webpack worked with it if we wanted to use it with Etsy, with its on-demand development builds and its 5-minute production deployments. OK, I'm drinking water again. So tell the person next to you what your text editor of choice is without trying to convince them that yours is the right one. I hope the answer was Vim, but it's OK if it wasn't. OK, our first order of business was to get a development workflow that was good. If engineers could develop with Webpack and validate that their code still worked with Builda in production, we could at least improve their development times while we figured out how to get Webpack to work in production. We wouldn't be able to offer new features like ES6 yet, since Builda, doing the production builds, didn't know anything about ES6 transpilation. But maybe we could make the engineers that had to use React on a daily basis have a good time doing it. So why does Webpack take so long to build? And that was the first thing we needed to figure out. When Webpack first starts, it does a complete build of all of your code first. And then it enters watch mode, where it monitors your source files for changes. And then it kicks off a partial rebuild every time it sees one. This pattern allows development to be extremely fast relative to complete rebuilds. We figured that the longer initial build coupled with rebuilds of a second or two would probably be much better. But if that initial build took a half hour and ate up all of our memory, a 2-second rebuild probably wouldn't matter all that much. On top of that, our code base was really big and it was only getting bigger, so whatever solution we came up with would have to scale. Why is it necessary to do a complete build of all of our code first, you ask? Well, Webpack makes inferences about your code in the context of your whole project. For example, it is smart enough to group commonly requested modules together so that they can be cached efficiently between pages. It can only make these optimizations if it understands your entire project, not just your individual files. This is good if your project is nicely scoped, but it makes a lot less sense in a monorepo, where everything from our internal tools to our homepage code all live. So we started by trying to make Webpack faster and less resource intensive in general, something that's really hard to do both of at the same time. We got a lot of mileage from caching plugins like Cache Loader and HardSource, and allowing Webpack to process our modules in parallel using plugins like HappyPack was certainly a good idea. But at the end of the day, we still had a prohibitively heavy first build time. I can't believe I found this image. It's amazing. We also looked at Webpack Development Server for potential solutions. The development server, by design, chooses to keep everything in memory, including its finished output files. For us, this meant that our whole code base, plus all the transpilation information about our whole code base, plus all of our built files from our whole code base, all had to fit in memory. If you remember, we have a very large code base. There also, unfortunately, isn't a way to turn this behavior off without modifying the development server's source code, which is actually really like a really nicely written repository. And if you're ever interested in how this sort of things work, I would totally recommend reading through the source. Even if there was a way to turn this behavior off, it wasn't clear that it would save us from ourselves and from the size of our monorepo over time. All of this put together made it sound like it was probably a good idea to keep Webpack from building the entire codebase all at once. One really easy solution was just to make a bunch of different config files for different areas of the codebase and only build the one that was being used at the time. We can make each region be small enough so that memory is reasonable and the initial build times are closer to 1 minute rather than 11. For us, this meant that splitting our codebase into 11 regions was the right number. We had a region for things like our seller tools, the core buyer experience, and our internal tools. This would have worked, but we wanted to emulate one of Builda's nicer features, quietly building files without any additional interaction from the developer. Juggling a bunch of configurations just to browse around Etsy on your work machine was not ideal. This meant that we probably needed to write something of our own. So we wrote a thing called Kevin. Kevin is a plugin for the Express web server framework. And its only job is to manage a bunch of Webpack instances. Why did we name it Kevin? Look how funny he is. When a request for any file comes in, Kevin determines which Webpack config is responsible for building that file, if any, and then it starts a Webpack instance for that config. Once the compiler is finished, it starts running that code in watch mode, rebuilding files as they're edited, much like Webpack's development server. If Kevin gets a request for another file in a different config, it does the same thing. If there are ever too many compilers running, Kevin will shut down that compiler based on a frequency algorithm, which is frequency and recency. This keeps us from building the whole code base, and it has the added benefit of making sure that the code base has regions of it that are all related to each other, rather than grouped into one massive blob. The only extra thing to consider is that really long first build. If a request for a JavaScript file times out after 30 seconds, and starting up a Webpack server takes closer to a minute, we're going to end up timing out in development for what seems to be no reason. It's a kid in timeout, that's the joke. Our solution was to just serve some static JavaScript that shows an overlay of what's being built if we just started up an instance of Webpack. It is modeled after the Domino's Pizza tracker. We also exposed some data about the status of every active compiler so that the overlay is able to monitor the status of its build and reload the page whenever it's done. The end result is a fully automatic process that keeps memory usage low and keep engineers informed about the state of all of their builds without requiring them to manage a build system. With any luck, Kevin will be available as open source software very soon. All right, another water break. In 15 seconds or less, tell a neighbor what you did for Adventure Day. Let me really quickly talk about productionizing our code, and then that juicy bug that I've been waiting for. OK, I want to talk about productionizing our code, but more specifically, I want to talk about localization, since there's a lot of other much less interesting things that went into getting our code production ready. So at this point on our Webpack journey, development was working. We even started to onboard a handful of developers so that they could start giving us feedback, most of which was pretty good because they could build all of their code much faster. Because we weren't building production code with Build-A-Pack yet, we were not quite ready to enable ES6 support. But the benefits of Webpack brought to the development speed were wins in and of themselves. Our next order of business was to get production to have that same speed. There is that chicken again, reminding us that we need to get 5-minute production builds. That is our goal. A working development environment meant that we were at least able to successfully build our own code, but we need to productionize it. This involved minifying it, But more critically, it meant localizing all of our assets into 11 different languages. Localization is a little tricky with Webpack. The general assumption is that for every locale that you want to support, you need to kick off a separate Webpack build. Webpack's localization plugin uses a file that contains localized strings that you provide, and your code uses a function to get access to those strings. It seems simple enough. Using this method, constant strings can be defined in one file and swapped out between builds without your JavaScript changing. There is an implication here that's a little tricky. Webpack ends up with a different configuration for each locale that you support because the plugin needs to be configured differently for each language. This meant that in order to build 11 languages, you need to run 11 different Webpack builds. For Etsy, one of our beefy primary deployment servers, again, 32 gigs of RAM, 32 cores, 64 gigs of RAM, it's big, it's really big. Could take as long as 5 or 6 minutes for one build. We could maybe run 2 in parallel and have the resources and get like 8 or 9 minutes for those 2 builds, but that would still mean that all of our builds take something like an hour. We were also constrained by the fact that we were actively moving Etsy from hardware in our own data centers to the cloud. While this was happening, we couldn't just ask for new hardware, let alone a dozen or so of the most powerful computers that we used to have. If we were trying to keep pace with Builda, which could get our code ready in something like 5 minutes, we were going to have to cheat a little bit. Luckily for us, cheating is okay, because Builda cheats too. Let me explain what I mean here. When it needs to localize a bunch of code into 11 different languages, Builda doesn't build that code 11 different times. Instead, it inserts placeholder strings around the places where the translations will eventually need to go. Later, when that build is mostly done and it looks like word salad, it goes back through each file, finds those placeholders, and swaps them out for actual localized strings in every language. If you speak French, you'll know that this is an accurate translation. Compared with Webpack's apparently deprecated internationalization plugin, this seemed like a much faster approach. I actually didn't know that this was deprecated at the time that I wrote this talk. So, like I said, JavaScript changes very quickly. Anyways, we tweaked our plugins that were responsible for providing translated strings and had them insert placeholders instead. Once the build was finished, we'd be left with a bunch of production-ready files with a bunch of placeholders in them. From there, a plugin that we wrote would iterate through our assets and do a find and replace, writing a copy of the source to disk with new locales inlined. This is actually a lot easier than it sounds. This whole screenshot is essentially all of the code, but here are the juicy bits. We're able to just take our source code and call .split on it with our placeholder. And the resulting array would contain original source code in the even indexes, and the strings that needed translating in the odd indexes. Would iterate through the odd indexes and translate them. In case you're curious, we get our translations from a separate service that we maintain, which just dumps static translation files onto all of our servers. This method was actually so fast that we were able to provide localization in development. This is why Kevin has Italian on his forehead. We could do this quick enough by translating things as they were requested, rather than building every file into every language possible. Thanks to this method, we were able to get our production builds ready in well under 5 minutes. Okay, very last section. I will go through it quickly. In 15 seconds or less, tell your neighbor if you can speak more than one language. For the last part of this talk, let me tell you about that 4 milliseconds that kept us from building this whole thing 3 months earlier than we actually did. So we were finally at the point where we felt ready to try Webpack-built code on production traffic. Very exciting. Development was looking good, production was building quickly, and a bunch of our end-to-end tests showed that things were still the same. However, build systems are very hard to replace. A new build system has to work in every language for every page on the site, like we talked about, but it also has to work in every single browser, no matter how old or how cutting edge it may be. If our page doesn't work, people will stop using our site, and we may lose money. So what do we do when we want to gain confidence in a huge change? We run an A/B test. This is an A/B test. It's a stock photo of an A/B test. We actually ran 5 separate ones, and they all looked pretty good. You can see all of the important metrics that we track say no change next to them, which is actually as good as we could have hoped. And yet, in spite of all this, we had some pretty alarming changes in every one of our browser performance metrics. Every page was running way slower than we expected. Some of our pages were up to 14% slower, which is unheard of. It's in a general rule, if your site's performance get worse, so does your site's money. So people were very scared about this change. We had to figure out what was going wrong before we could launch Webpack. Before I go on, let me talk about our client-side metrics really quickly. Many of you will probably know this sort of thing, but some of you may not, and I hope that this is a good refresher. At Etsy, we track a lot of things, but 2 things in particular when we're looking at client-side performance. One is DOM content loaded, and one is page load. So when the browser parses our HTML, it goes through line by line and evaluates everything one line at a time. For most resources, like this style sheet, it downloads and executes the whole thing before continuing to parse the page. Some things, like this image tag, will kick off a request, but will not block the browser from continuing to parse the page. Here is our JavaScript at the very bottom. Like CSS, JavaScript is downloaded and executed before the browser can continue. Some JavaScript code, like our network request or our timeout calls, do not block the browser and are added to a list of tasks that the browser can take care of at a later time. Finally, when the browser finishes parsing all of our HTML, it fires the DOM content loaded event, which says that the structure of the page is complete, even if we're still waiting for that image. There it is. Once all of our sub-resources load, that is a thing that you can buy on Etsy.com. Once all of our sub-resources load, like that image, and when the browser has run out of tasks to immediately take care of, it says that the page is done and fires the page load event. To recap, DOM content loaded fires when the page's structure is in place, and load fires when everything else is loaded and no scripts are waiting to be executed. Both of these were slower for us. This raised two questions. One, what is so small yet so different that we missed it? And two, if something is so different, why do people still buy things on Etsy.com? So we started by investigating our performance monitoring code, and we double-checked that we weren't shipping any extra code to our clients, but both of these things turned up nothing. So we decided to investigate how our code was running in the browser. This is a flame graph for our listing page, which is the page that shows an item for sale on Etsy. The graph shows our code built with Builda. Here, the horizontal axis represents time, and the vertical axis represents layers of execution. Every rectangle represents a function call or a piece of execution, and everything below that rectangle is a subtask related to it. This particular slice of the graph shows what the browser does when it parses the main JavaScript file on this page. Seems pretty quiet, takes about 18 seconds. Now what does Webpack look like? It looks a lot worse. This is the same file as the previous graph, but it's taking 4 times as long. For kicks, here they are side by side. Clearly, Builda is doing a lot less. So this is kind of concerning. So why is this happening? Even if our conversion numbers look good, this big difference may mean that we're missing a performance win. Let's take another look at the whole flame graph built with Builda. This is roughly the area that we were looking at before. This is where DOM content loaded fires. This here is page load. And this is apparently where our JavaScript file was actually getting executed. So zooming in a little bit, that rectangle right there is the main body of our JavaScript file, which for some reason is getting executed much later than we thought. So it seems like Builda's code is running well after the page load event has fired, which doesn't seem to happen with the Webpack code. In other words, our performance metrics were not accounting for the time it took to actually run our JavaScript, but rather when the built code with, when that JavaScript was built with Builda. Code built with Webpack did not have this problem. So we know why people are still buying stuff. The same things have happened, but our measurements have moved. We needed to know why this was happening. So let's look back at our 2 metrics. Specifically, let's look at load. And very specifically, let's look at that part that says that there are no outstanding scripts waiting to be executed. What if something was telling our scripts to wait a second before running, tricking the browser into thinking that the page was ready? Very quickly, because I know I'm like very over time, let's dig into the meat of require.js. As a reminder, require is the library that Builda was built around. We sent a copy of it to our browsers, where it's responsible for starting up our code and managing our code's dependencies. Here's where require.js kicks off our execution, and it's wrapped in this next tick function. What does that do? If we dig a little bit further, it looks like it's just a 4 millisecond set timeout call. This would tell our browser that our code can be executed 4 milliseconds into the future. This isn't a hard and fast time, and the browser is totally allowed to push things back a little bit later if it needs. In other words, require.js tells the browser that none of our code needs to run right away. Require.js may do this because it gives the browser a second to finish loading the page before starting any JavaScript. It also might do this because set timeout was a really popular way to make your performance numbers look good in 2010. It's hard to know for sure, but we know that Webpack does not do this, so it's a lot more trustworthy. So knowing that this was the bug, what did we do? We did not wrap all of our code in set timeout calls. That would just make our numbers look better, but it wouldn't tell us anything that we needed to know. But we did add some new metrics to help validate that Webpack code wasn't that slow. We added a timer to every one of our top 5 pages. Here, yellow is Webpack, and lower is better. Those timers were supposed to measure how long it took for all of our JavaScript to run on those pages. We were very happy with this graph. OK, I'm about done. In conclusion, it took us almost a year and a half to move to Webpack. That is a very long time, and that's a lot of hair pulling. We really hoped that they would be the silver bullet that would solve all of our problems out of the box, but at the end of the day, we had a lot to learn about build systems, performance, and our own code base, regardless of what we migrated to. I felt like there should be a 3-point slide thing, but there were so many winnings that we had that it's kind of hard to pick just 3. But I tried anyways. Number 1, your code base gets bigger, not smaller. If you're trying to find small performance wins to get your build time under some threshold, it probably won't last very long. A solution that anticipates your problem going twice in size will always win out. Number 2, always question what other companies, websites, articles, and blogs claim to be best practices. What works well for one person may not always work well everywhere. If we accepted that Webpack's internationalization plugin was our only option, we'd still be waiting an hour for our JavaScript to build. And finally, if you can afford to take extra time on a big, risky project, you absolutely should. One of the nicer parts about our migration was that no one was critically stuck on our work. We really hated that metrics bug cost us months of time when we were so close to being done, but we ended up learning so much more about performance, the browser, and our code. And at the end of the day, after almost a year and a half of wild problems and pulling my own hair out, Webpack is still pretty great software. So that is my talk. If you have any questions, please hit me up on Slack or on Twitter. If you like this stuff, my team is hiring. And of course, thank you all so very much.